Hi everyone, today I want to introduce some basic steps of how to run a job on the UT supercomputer Isaac. So here I used Windows PowerShell as the example. So first enter this command SSH and remember that the JLI139 is my account. You can change it to your account. When you press enter, you go to here. You need to enter your password. This is the same process of you enter your UTK accounts, and you need to use a door to verify it. So then you in the Isaac node now. So first we can use the pwd, which is show the current directory. However, we won't run the jobs here. So cd is another command which is change the directory. You can go to the directory you want. So here I just type the path to the work directory I usually go. So it's Lustre Isaac. So here, when you watch the video, this already changed to another file system. So you will use the Isaac24 instead of Isaac. So now I'm inside my working directory, and I'll go to the directory camp. So the ls means you can show the files you have under this folder. So there are several, and I use the pwd. Still, we can show the current directory path. So mkdir is you build a new directory. Here we can do a test1. So you cd to go to the test1 folder. So now you are inside the test1 folder, and you use ls. So it's nothing should because it's an empty folder you just built. So if you don't quit this one, use the cd important. This is go back to the upper folder, so which is the camp folder. And another common used one is the cd dash. Cd dash go to the folder you are at the last field folder you are in, and then you use cd dash again. You come back to the camp folder. Now I will introduce the VI. VI is common to edit or to view a file. So I just press the 1, 2, 3. So which is a new file. There's nothing inside. So now you press I. You change to insert mode. You can start to type something here. Like I just type some number here, and then you press ESC and quit this. And then we need to if you want to quit, we need to type the column Q, which means quit, and the WQ means you saved and then quit. So here, since I already added this file, you need to use the save quit, which is WQ. So ls again, we can see the file we just built is shown here. So with VI it again, we can see the content we just entered. Now this time we just use a Q. So we quit because we didn't do any edit on this. Okay, now I'll introduce the submit script. So this is the basic format. We'll introduce one line by one line. The first two lines we basically don't change it. The third line is job's name. The fourth line, the ACF UTK0011 is something, the account. You need to always use this one if you want to use a camps node. So this is a node's number. I will use one node, so maximum is 6 nodes. And the next line is ntest per node. So basically, how many core you will use for one node. So every node have 48 core. We'll just use 48. And partition, remember you need to use the campus nodes. The time is a time limit. The maximum is 24 hours. So I use 1 hour. The arrow and output is information you output to these two files. And the QoS also campus. The node list is now important here. It's define the node you want to use. And then you need to run the job. So here you need to use these two modules. So I use the module unload and the module load. And then I will use the lamps I download by myself. So I will use this command. So if you have your own lamps, you need to change it. And then I will run the S run. So which means I will run the lamps, and also the input script is called minimize.in. So now we can look at the minimize.in. So here is a very simple minimize script for lamps. First units, you use the metal, and then dimension, you have 3 dimensions, use 3. Boundary is periodic boundary, all 3 directions use periodic boundary. Atom style is atomic style. To read the data, this is the data name you need to define. So remember, basically all the comment here you can find them in the LAMMPS menu. So they will give you a very detailed explanation. The pair styles, so here show you the interatomic style. So so here I used the machine learning potential. And the thermal 100 is you output the information via 100 steps. The thermal style is I define I will output the step, the total energy, the price, etc. And time step is the 0.001 picosecond. Minimize style usually we use a CG. The fix, which is fixed, make the box also relax, so the stress will be 0. Then you run the minimize and fix. Minimize is the first 2 is the criteria, and the last 2 is the steps, the max steps. Then we use the dispatch campus. So the dispatch is submitted the script you want to run. So now the job is submitted to the system, and it will queue it. Since it's we have empty node, so it will run it directly. So now you can see that you have the output file now that we can via the log.lamps. It shows the simulation. So you can see after about 800 steps, it's finished. And the time is only 1 second because we only have 250 atoms. And then we can via the output file after the minimization. So you have this file is LAMMPS data file. So it shows the information of the system, like atom numbers, the coordinates, atom type, and atom ID, etc. So we cannot read it directly. We can try to use other software to view the configuration. So first we use something to transfer the file. So here I use the FileZilla. There are several different ways you can use. So the step is same like you log into the cluster. So I'll go back here, use pwd show the path, so I will just copy the path. Then we go to here, we find the file we want, we just download it. Okay, it is downloaded. So we go to my local computer and open the Ovito, which is the software we use to view the system configuration. So here we first see the system before the minimization, and then we can view the after minimization. So the difference is very small but if you can zoom in, you can see there are small distortion for the atoms since they are HEA. And then here I use a common number analysis to do to see if they are BCC. The blue is a BCC, and then I use the coordination analysis to show. You can see that they are not perfect crystal. They have some small distortion. So thanks everyone. That's some basic steps